Okay, today we'll talk about linkage, software for design and okay, and analysis actually of linked system. We'll start here. All right, now we go to screen. Okay, the screen here starts with four-bar linkage as an example. Okay, since I'm going to use different units, so I just say recalculate here and then go back. For units, I want to adjust the units. So now we can start here. For the crank, we start with an example of 0.1 meter. Now coupler, we make it 0.4. Okay. Rocker, we make it 0.5. And I select here 0.7 for the ground. Angle 0 distance, we use the point P. Point P would be the same location at point B. P for people would be P for pot. So we use the same number here, 0.4, and the angle is 0. And we start with an angle 0 and then say recalculate. So this is the shape we obtain. So here is the, we call this one as O2, O4, center of the crank, center of rocker, and this is the ground. We can ask it to run in steps of 60. I can make step of 5 here. Maybe I can change here. You have to press enter every time. If you do not press enter, it will not be reflected. Now we say run. See how the rocker will go. Start with the given point here. This is one extreme here, and there is another extreme, the other side. See here, there's another extreme. Those are the places where the rocker is permitted to move. This angle is made by rocker. This angle is made by rocker. Okay, now if we want to have, if you want to print this, we go here. We go to next, and then over this, let's say print here. Better to go and say plot. And we say theta magnitudes. Okay. So theta here for the here. So we can see here theta 2, which is the crank angle, starting from 0 and end up with 360. Okay, this one is actually is more than 360, it's 405. Now theta 3, theta 4, theta 4. See, theta 4 is fluctuating, something like here, theta 4 is between 134 and 158. So the angle made by rocker here is the difference between them. Here we have transmission angle. Okay, we have maximum. Usually maximum means 90. Minimum is 54. Where is 54? 54 is appearing somewhere right here. 44 here. This is the angle is 54. So this shows the how to use the. Again, we are coming here. Recalculate. This is the shape. Now this position here at this position. Okay, this is the Grashof conditions for sure. This at this position, this angle here shows one of the minimum transmission angle. This is one case. The other case, if you change this, make it one, then say recalculate. Now this angle, but we are looking for acute angle, so it's the other way. So it has two minimum transmission angle. This is the case for minimum transmission angle. Those are the places. Okay. Here, see one case of interest here. This is one extreme. This is one extreme of the application of point B, which is the a rocker point here, moving point, moving pivot. If you go, just increase here and then check what happened. Then we find another. I think we should make it here. Start with 0 and make it. Okay, then I just. So the smaller angle, the smoother the results you obtain. So here somewhere, you see the crank and coupler are aligned here. Both of them are aligned. See, they become like one line. Just now, here we go. They appear as if they are one line. Okay, this is one case, this is one extreme. If you go the other way, if you increase, they will go the other way here, and we have another extreme point. See here the angle here shows you the angle. What angle here? Crank angle. This is crank angle. We move here. So we should stop somewhere here. Of course, this is Grashof. Make it here. I'm going to change, make it one position here. And we'll make it 120. Make it 300. Calculate. 300. $60. We calculate, which is 0. I'll make it 40. We calculate. See somewhere here. Let's change, make it constant 50. The angle, I make it. Recalculate. Somewhere here, 40. Recalculate. See here, if increase step here a step, here almost straight line. See, this is another extreme. Okay, this is all for the 4-bar linkage. How to use 4-bar linkage for the sake of the analysis for the 4-bar linkage motion. This is regarding the geometry here. This is regarding geometry. Okay, thank you.